So how many people have already played a bit with PySpark? I guess not many. Okay, yeah, 10% or less. Okay, so we were actually not planning to give a really basic overview of Spark, but we're gonna spend 2 minutes just giving some definitions of the Spark concept. And then the idea is that we had 2 parts prepared. The first part we're going to cover Spark core. So this is the core functionality of Spark, and we've got some questions and exercises if we have time, and talk a bit about the Spark execution model, which it's very important if later on you're building full-fledged applications and it doesn't work, or it fails, or it's not very performant, and you need to understand a bit how it works behind the scenes. And the second part is, so it's my colleague Sahan is going to do it. It's about Dataframes and Spark SQL, which is a new thing that came with, I think, from version 1.3 and 1.4 as well. So yeah, it's just a new feature. Okay. So these are just some, very briefly, some definitions of Spark. If I had to give a crash course in 2 minutes of Spark, this is what I would say. So Spark uses something called an RDD, which is stands for Resilient Distributed Dataset, which is a distributed dataset. Okay. So let's imagine you have a huge dataset, and you have to divide it into partitions. Okay. So that's a word that I'm going to be using a lot, partitions. And so Spark gives you the possibility to cache data in memory. So that's quite nice. And then in terms of data manipulation, so usually you would use Spark in a cluster, right, where you have a master node and some slave nodes. And we can apply transformations to the data through the Spark context. Okay, so it's another important concept, the Spark context. And only the master node has access to that Spark context. So you can only, tell Spark to transform your data through the Spark context, which is, you can control through the master node, from the master node. I hope that's sort of clear. But okay, so these are the data sets that we are going to be working with. They're a sample data set from Amazon. There are 4 of them, so 3 of them, they're JSON files, so fashion, electronics, and sports. They are product reviews. And the other one, sample metadata.json, there, it's metadata about products. So you will have the price, the category of the product, and other information about the product. Okay, and also credits. This come from 2 papers. Okay.
Excuse me, I have one question.
Yeah.
Dropbox doesn't seem to be working.
So which link are you trying?
The one I got in my email.
Yeah, sorry, that one doesn't work. You should try the one that's on the instructions. Sorry about that. It's a last-minute change. Okay. So now I'm going to go to my IPython notebook. But again, everything I'm going to be running here, if you've got the shell, you can just start running as well. All right? So you can just copy and paste what I'm... what you have to do is, once you download, if you want to run this exactly as I'm going to be running it, if you download the folder, you have to go into the folder after you unzip it, and then you launch PySpark once you're inside the folder. Yeah, because otherwise the paths, these paths are all relative to you being inside the folder, otherwise it won't work. All right, so, first steps, creating an RDD. So as I said, an RDD is a distributed data set. So what we can do is, in the shell, you already have this variable sc, which is a Spark context. So if you want to attach a text file or some data to your Spark context, you use sc.textfile, okay? So in this case, we're creating 3 different RDDs, one for each text file that we have. So one for the fashion reviews, another one for the electronics reviews, and another one for the sport reviews, okay? So I'm going to be running this now, right? Okay, done. So as you saw, so just one note, as you saw, I just ran these 3 lines, and it took very short time. And it's because no data was actually moved or read or anything. This is part of the lazy evaluation of Spark. right? It just, it's very lazy, it doesn't actually do anything until you trigger an action. In this case, this is not an action. This is just like a definition of, fashion is an RDD, and the data is in this file, okay? All right. Now, we've got the next thing we can do is count the number of rows in the RDD, okay? So what you can do is you take fashion or electronics, and you just use this function .count, and it will tell you how many lines there are in each RDD, in each file. And finally, you can also use .first to just get the first element of your RDD. Okay, so as you can see, fashion has 10,000 rows, so does electronics and sports. And then the first row, so it's a string, and you've got all these fields. So you've got the ASIN, which is a product identifier for that, the Amazon product identifier for that specific product. And here you've got the review text, so somebody bought a tutu, and the overall, which is a score, and other fields that could be interesting. Then another thing we can do is to union like multiple RDDs. Okay, so in this case, I want just a single RDD that contains the data in those 3 files. So one option is to take the union of those 3 RDDs. Okay, and that's what I'm doing. And as you can see, again, the first line is the same thing as before. But now this union of RDDs contains the data in the 3 files, so in the fashion, electronics, and the sports one. So, okay, so this is basic, loading a file, creating a union of RDDs, counting the number of rows, taking the first element. Now, let's imagine that, so we've got this RDD, and the first row looks like this. It's a string, but really it's a dictionary, and we would like to have it in, as a Python dictionary. We don't want it as a string. So that if it's a Python dictionary, then you can just call, the different fields directly. You can say, give me the ASIN, right? So for that, we are going to use the JSON library in Python, and then we can just apply a mapper. So a map basically will take the data and will apply the same function on all the rows of your data set. So in this case, we're telling it, take fashion, which is an RDD, and on each row, you apply this function json.loads. And by doing this, we're turning, so what previously was a string, now it's a dictionary. Okay? So this is, if you've used Python, it's like the map function in Python. It's very similar. Okay. Another thing you can do, so instead of having to create one RDD per file that we want to work with, that's, if you have 10,000 files, that's a little bit tedious. So what you can do is just pass in, a list of comma-separated file paths, or use like patterns, right, wildcards. So in this case, we're just going to give, this list of comma-separated files to the Spark context. And if we do that, then we just have one RDD with all the data. Okay? Now, this is a question. So if I do that, how many partitions do you think I will have in my RDD? Yes. Does anybody know why it's 3? So when you load a text file, right? Spark doesn't know anything, doesn't know how to partition your data. So a priori, it will just take as one partition per file, right? So that's it. So you've got 3 partitions in this data set. And this function get non-partitions, I personally find it really useful, because when things break, or the number of partitions is always something that, as we will see later, you need to tune. So it's always important to understand exactly, how many partitions you have throughout all your operations, if you need to debug your code at some point. So just remember, get non-partitions, very useful. Oh, something I forgot to say, actually, is that a very, very useful thing of Spark is that you can go into the application dashboard. So in this case, it's because I'm running PySpark locally, right? It's just on my local host, but otherwise you would put in here, let's imagine that you use EC2 instances on Amazon, you would just put the IP address of your master node here, and then you can go into this dashboard, and this tells you exactly, for example, how many executors you have. In this case, because it's local, it only shows one, but normally I would have like as many executors as I have nodes in my cluster. It tells you like all the properties of your cluster and whether you've cached anything. So the storage here tells you, whether there's anything sitting in memory. And here, okay, we don't see anything at the moment, but normally if you run something, then it will start showing you what you've been running. Okay. Yes.
So far we have uploaded
Yeah.
Is there a way to load with the structure? Because
I mean,
structure directly.
so.
Creating the map afterwards.
Okay, so Sahan will cover a bit of this. So with Dataframes, you can actually, define a schema, and you can tell it's a JSON file, and it has these columns. But yeah, so maybe wait a little bit until later. Yes? So you don't have the proper, sorry, I just don't hear. It's a pity you don't have like a microphone or something. Oh, there is a microphone? Oh, that would be amazing. Okay, thank you so much.
So I think you were on the 9026 port, right, for the monitoring?
To do what? To
when you were monitoring the Spark job, just before that.
This one?
No, sorry, you were in a...
Oh, to launch
Yes.
the web UI, yes? This?
Okay, yes, that one. When I run that in a EC2 instance, most of the time I can't navigate the
You don't manage to log in like, to see this page?
I only see Spark stages, basically. And if I run something, I have a link, but I can't do anything with that link. Is something you encountered before, or?
Okay, no, sorry, I'm
Okay.
not really sure what's the problem. Sorry about
Thanks.
that. I mean, sometimes if you have a cluster of EC2 instances, it might be that you have to look at your inbound properties and outbound. So sometimes maybe you need to go into the AWS account and check some of the configurations of your cluster. Oh, okay. Maybe later you can show me like more. Okay, so we're here, right? So this is another function, okay, map partitions with index, which I think is very useful. Now, before we had a map, right? And map applies one function per row in your data set. Now, map partitions applies the function on the entire partition. So it's slightly different. And here I put a link. So the documentation is here. So if you ever have any questions about what is the functionality of Spark Core, what kind of functions can I apply, there are some examples as well. So in this case, you can also find map partitions, right? And it tells you, it gives you a couple of examples of how it works. So in this case, what I want to do is count the number of lines per partition. Okay, not the total number of rows that I have, but like how many rows do I have in partition 1, in partition 2, and in partition 3, right? So map partitions with index gives you two variables. One of them is the partition index, and the other one is an iterator over your data sitting in that partition. So then here, all I'm doing is just taking the length over, the whatever is in the partition. And collect is another nice function that you should be aware of as well if you use Spark, which is basically when you take all your data that's sitting in your slave nodes for that specific RDD and just collect it in the master node. And then it's just like a Python, normal Python object, and you can do whatever you want with it. So in this case, what I see here is that I've got, as is expected, 3 partitions, so 1 per file, and the number of lines per partition is 10,000. Again, it's as expected, because we had 3 files where each of them had 10,000 rows. So nothing weird happening. Okay. Next thing, reducers. All right. So how many of you are just familiar with MapReduce paradigm in general? Okay, that's good. Yeah, quite a few. So something that is very core to the Spark is this idea of reduce by key, which is part of the MapReduce paradigm. So let's imagine that we want to know the number of reviews per product, okay? To have an idea of how popular each product is. So something we can do is take our data, so our data has all the product reviews. We take the asyn of that product, and we count it as 1. So we say, this product has been reviewed once. And then we do a reduce by key, where we just add the values of 2 tuples. So the way it works, and here I've done a little diagram, okay? So let's imagine, one product is asyn 1, okay? And we have 5 reviews for asyn 1. So what the reduce by key does is that it will take 2 tuples at first, right, where the first element is the asyn and the second element is a 1, and it sums them. It sums the values, right? So in this case, you have asyn 2. Then it takes another one, and again, it will do that again. So we will take the 2 values again, and it will sum them. So then you have asyn 3. And it does that over the data until you get, the final answer, which is you have 5 reviews for asyn 1. So this is a sketch of how reduce by key works. So in order to apply reduce by key, or in general, any function that has by key in it, like group by key or by key, then you always have to have key value pairs. So your data has to be in the format a key that has to be hashable, and a value, which could be whatever. It could be a list, could be text, could be whatever you want. So in this case, the key is the asyn, is a string, and the value is 1. And then here, x, y is the values of 2 different tuples, right? So 2 1s, or a 1 and a 2 here, for, to get 3. So you get the idea. Okay. So once we do that, if we want to know what's the maximum and minimum number of reviews in a product, then it's very simple. We just grab the second field of product num. Okay, so product num contains the asyn and the total number of reviews, and then we just take a maximum over that. And for minimum, we just take the minimum, and that's it. So we run this, and it tells you that the maximum number of reviews is 2033, and the minimum number is 1. Okay? So I had an exercise here, but I think we're probably running out of time a little bit, so I'm just going to leave that. But you can do this on your own time. And the question is, what is the maximum score now for each product? So how can you create an RDD that has the asyns and the maximum score for that specific asyn? Okay, and it's basically, like a little spoiler, it's the same thing as this, only instead of adding the scores, you take the maximum over 2 scores. Okay. Good. All right, next, joining multiple sources. So we've only been working with the product reviews, but we also have this metadata that we could use. So, okay, so we're just going to start by loading the metadata that we have. Okay? And as you can see, the metadata also has the asyn and has information about the products, like the title of the product, the image URL. We have the categories. So the categories are encoded as a list of lists. So we're going to change that right now, like next thing we're going to do. Okay, so you've got lots of useful information. Now, okay, this is just because we don't like this list of lists thing, so we're just going to flatten the categories so that it only shows one list. Okay, so this is what flatten categories does. You don't need to look into the code too much. Just take it as a given. It takes a list of lists and outputs a list with a flat structure. So we're just going to apply that. Okay. Now, next, yes. So we want to join the reviews with the product metadata, right? So we want to know, person reviewed this product, and we want to, I don't know, for example, know the category of that product that the person reviewed, right? So what we need to do is we cannot just apply a join. And again, as with many operations in Spark, you need to have key value pairs, right? So we're going to start by taking the reviews, and we transform it into key value pair, where your key is the async, and the value is just the whole review, field. And for the metadata, we do exactly the same thing. We take the async as a key, and then the rest of the metadata in here. So, okay. And once we have key value pairs for the data and the metadata, then we can just apply join on it. Okay? All right. So as you can see, this is the output of the join. This is the key that was used to join. So it's the async. This is the product review for that, a specific product review for that async, and this is the metadata that we have about that async, right? So again, what is this? Yeah, basically it's just some gadget, BlackBerry gadget. Good. I think I might skip this. Okay, this is basically what I was trying to show here is that, if you want to know the number of partitions of a joined RDD, it's actually not an obvious thing to know, like unless you know exactly how the join is performed. So something that Sahan and me have to do all the time, if we want to know exactly how it's done, right, inside, is that we just go to the, PySpark code. Going to the code, the Python code is always a good idea if you're trying to figure how things are done, right? So yeah, it's just a little side comment. So in this case, the number of partitions for a join is the number of the sum over the number of partitions of your two RDDs that you're joining. Okay, but it's not a trivial or straightforward thing. It's just you need to go to the code to check how it's done. All right, so now we've done this. Okay, you saw that the structure is actually not very nice looking, right? I mean, it's like a tuple where the second element is a list of dictionaries, so it's not very nice. I just want a single dictionary. I want to make it nice, right? So what I do here is that I just say, okay, merge the two dictionaries from the metadata and the reviews. And I do that. So I do that, and then I just get a single Python dictionary where I have all the information here about a specific review, but I also know something about the product, like I know which category it is, and the title, right, and lots of things like this. Okay. So this is just a couple of questions to probe your understanding of Spark. So this function here, change title, takes the title field, right, of a dictionary and changes the title, right? So I'm going to apply this to the previous structure that I showed you, okay? I'm going to call it categories, the new RDD. And the question here is that if I print this, right, which is basically taking the title of the first element of categories, what do you think it will print? Okay, so previously this was a title, like privacy, screensaver, blah, blah, blah. And now I apply this function, it's just gonna print like, this is the title, right? I mean, so far so good, okay, as expected. Now this is when it gets less straightforward. What will it print if I take now nice join, which was my original RDD, and I applied, no, sorry, and I don't apply anything. I just want to print the first title, right? So in this case, it could either print this is the title, or it could print the original one, right? And it's the original one. So what I'm trying to show here is that, okay, we've applied some operations on nice joined, but these operations are attached to a new RDD, okay? We haven't changed the original RDD. We just created a new RDD. It's just like, a new Python variable that contains like, these transformations and this data, but the original one has not changed. It's still the same. And this I'm gonna give it for you, in your own time if you want to check this. It's a little bit, it's more tricky, but I think it's worth not, I'm not going to do it, basically. Yeah. All right. Next thing, group by key. So, actually I have some slides. I think we're kind of okay with time, so I'm gonna do the slides. So, all right. So something that Sahan and me have learned now after using Spark for a year is that understanding the Spark internals is definitely worth it, because a lot of times your job doesn't perform as you expect, or it fails, or it hangs, and if you don't understand exactly what it's trying to do and how your data looks like at that time, or how many partitions you have, then it's just very difficult to debug it. Okay, so I really recommend this talk here. Put the link there. It's by one of the founders of Spark, and it's a very good talk, and he gives a lot of really nice examples. And I just tried to copy some of the things that he was saying, but very condensed version here. So how does the Spark execution engine work? Okay, so let's imagine we have this code, right? What we're doing is what we've been doing before. We're loading product reviews. We're applying a map function where we extract the ASIN and the score. Then we group by key, right? Where we group all the product ASINs. So we group all the scores for a specific product ASIN. And then we just filter. We're only interested in the ones that have been scored at least twice. And then we count the number of products that have at least 2 scores, okay? So this is how our data looks like. This is the ASIN, this is a score, okay? So at first, this is the output of the mapper, right? Because we only get these 2 fields. Then we apply group by key. So we group all the rows by product ASIN. So in this case, we have just 1 score for this product ASIN and 2 scores for this product ASIN, right? So when you group by key, you end up with, as a value, you end up with a list of scores, right? And finally, we filter the ones that have at least 2 scores. So this one is not interesting, so we throw it away. And then we count the number of products that pass all these constraints. Okay, so just simple example. So what does Spark do? Okay, so you have the code. The first thing is that this is more conceptually, but it creates a sort of a graph of RDDs, where it's just a sequence of operations that you apply on your RDD. The first one is the map, then the group by key, and then the filter, right? So this is very simple. I mean, you probably also do this when you're designing code or in your head, like these are the steps. This is each step of the pipeline, right? But then this is where the tricky part comes. Spark figures out what is the best way to execute these operations. So in order not to have to iterate over the data multiple times unnecessarily, it will try to, for example, take 2 different map functions and then just fuse them into one single operation, okay? So it will try to fuse operations as much as possible. And, but you can only fuse so much, right? For example, if you have a stage or you have an operation that where your data has to be reshuffled, right? Or your data has to be reorganized. Or, in this case, in the group by key, the output of the group by key depends on the output of the previous mapper to be finished, because this partition here will depend on 2 different partitions in the map level. So whereas before, like for example, in the filter, it's a linear operation, right? So you filter 1 partition, and it's completely independent of what the other data looks like. But in the case of the group by key, no, it's not independent. You depend on the previous computation to be finished. So this is when Spark creates this idea of stages. So it takes computations, puts them together, and it says, okay, this is 1 stage. And you can only start the next stage when the first one is finished, right? So that's all I wanted to say. And then once he has done this, optimization, then it schedules the tasks and executes them, okay? And this is a shuffle, okay? So a shuffle is basically an operation that, as I said earlier, that involves reshuffling of the data. It involves the data having to go to places, right? So there is some network overhead here because you need to send it, the data from one physical place to another physical place. And in this case, for the group by key is a shuffle because you want to group your data by the asins, right? But for example, this product, right, might be distributed in all the partitions, but you want to group it in a single partition. So what you will need to do is take all this, the instances of this asin, and send it to the same bucket. So send it to the same place, the same output place, which is what it's doing here. So we take this specific asin, sit in here, here, and here, and we have to send it here to the same place. So as you can see, this operation is not linear at all, and it's okay. So it's what we call a shuffle, and in our experience, they've tended to be the bottleneck for most things that we're trying to do, because you can imagine that if you have a very large task or a very large partition, then you will run out of memory at some point. So if one of those blue things, which has to sit in memory, is huge, then you might run in problems, into out of memory problems. The other thing is if you have too many tasks, then there's too much network overhead because you need to send too many files, right? So this is another thing to bear in mind. If you have too few tasks, then you might not be utilizing the cluster optimally, so maybe some nodes are not doing any work. So again, something to bear in mind. So in the talk that from the Spark founder, this is some of the guidelines that he mentions. So you usually want between 100 and 10,000 partitions. You want it to be at least twice the number of cores to make sure that your cluster is fully utilized. And you want a task to take at least 100 milliseconds, because if it takes less, then you probably, there's a trade-off between network overhead and how big your partition is, right? So if it takes less than 100 milliseconds, you're probably having to send too many files around that are too small. So it's, you can probably increase the size of the partition. Okay. So the last bit of my part of my talk, this is a group by key. So yeah, I'm gonna go just very, very quickly over it. In here, what we're trying to do is we want to count the number of reviews per category, okay? So just as a reminder, this is what nice joint looked like. First. So nice joint was a big dictionary with the review and the metadata information. And we want to just count the number of reviews per category. And the categories are a list, so are encoded as a list. So what we need to do first is a flat map. Okay, we need to flatten this out so that we count, for this specific review, we count category electronics has been reviewed once, computer and accessories has been reviewed once, and so on, right? And so this is what we do here. We do a flat map with the categories. Okay. So we're going to do this. So as you can see, we have 925 categories, and this is the output of the flat map. So we're only taking 5 elements, and it's not a list of lists anymore. It's just basically it's not a list of lists. Yeah, it's just flattened out to be only single categories. Now what we want to do, we want to count the number of reviews per category. So we do the same thing we did before. So after the flat map, we're going to do a reduce by key, where we are going to count the number of categories, the number of reviews per category. Okay, and again, you can collect. So this RDD category total count has the category and the total number of reviews in the tuple, so you can collect it, and then you can perform any operation you would do normally, like in normal Python. So in this case, I want to sort them, and I want to check what are the top 5 categories with the most number of reviews. Okay. And okay. And yeah.
So you collect this all with supply.
Yeah.
How small is it?
So, is how much your Python, like your driver can take. So if you can take like, 1 gig, around 1 gig, 2 gigs, maybe 2 gigs is too much. In my experience, like 1 gig.
Is there any way to check the event if given all?
So what I do usually, well, I mean, a simple thing is to check one row, see how many rows you have, and multiply by the, the expected size for the row. But another thing that I do is I cache it. So you can do nice join.cache. So let me see if I can do it now, actually. So nice join.cache. Okay, and then I count. Nice join.count. So yeah, count is I need to count because it's an action. So unless you have an action like count or collect, then because of the lazy evaluation, it won't do anything. So you always have to count. And in this case, I don't really know why it's not showing me anything here. Damn it, I don't know. Normally, the web UI, you should see here the RDD, and it should tell you how many partitions you have and the size of memory. That's what I do. I don't know why it's not showing here. Maybe it's something with the fact that it's local. I don't know. But that's another way that I check the size of my RDD. Okay. So yeah, going back to what I was trying to do here, this is just to show how to use group by key. So in this case, I want to group so I want to get the average product review length for each category. Okay. So what I do is I want to group all the lengths of the product reviews for each category and then get the average, right? So what I do is here, it's a flap map where I take the category as a key, and this is the length of the product review. And then, so let me show you an example, okay? So after the group by key, for example, this is telling me that Screen Protectors has 10 different reviews, and these are the lengths of each review, okay? So this is after the group by key. And then what I do is I take the average, right? By taking the sum over all the lengths and divide by the number of product reviews. In this case, like the average of Screen Protector is 423 characters. And again, you can collect and just check it out on normal Python. Okay. So this is it for me. Again, I had here a little exercise that you can do in your own time, and then a couple of notes about data skewness. So this is a very typical problem that you will see when you deal with real data. So again, you can check this out in your own time. And I also had this is how to broadcast a variable. And in this case, we were broadcasting a scikit-learn object to apply it on the text data and predict something out of the text data. But we don't have too much time on it, but you can run this later on. So now my colleague Sahan is going to talk about data frames. Woo! There you go.
So you guys want to have like a 2-minute break, like a really quick one, or should we just go straight ahead?
Go straight ahead.
Okay, cool. Let's do that.
Yeah, we can share that.
Yep. So, good morning everyone. I'm Sahan. I work as a data science engineer at Skimlinks. So, earlier, so in the part 1, Maria was talking about, the Spark core. And in my part, it's all right, yeah. So, in my part, I'm going to focus on 2 things. That's the first thing is the Dataframes API and Spark SQL. So we start. Okay. So what's a data frame? A data frame, the definition of a data frame is it's a collection of data with named columns. So the collection of data part is as same as the RDD concept. But then in addition to that, a data frame has column names. And what is SQL? I mean Spark SQL. It's the same, I mean it's a SQL-like language which can be used to query from big data using, from RDDs, like data frames. So before we start, how many of you guys have worked with pandas data frames? Good. And how many of you are familiar with R? Okay, I've got good news for you. So data frame API is very similar to pandas R data frames. And let's get to the second part. Who hasn't worked with SQL? That's a bad question, isn't it? Who's worked with SQL? Okay. So who's worked with Hive? Okay, good. So Spark SQL, in an essence, it's pretty much, it has this Catalyst SQL engine, which takes in SQL-like queries and optimizes them and, scales it up to work with petabytes of data. And then in Spark SQL itself, there is this component called the Hive context, which can be used to be more creative, add more HiveQL, HQL functionality with your data frames. So before we go to the tutorial again, let's just quickly catch up. I mean, yeah, there's RDDs, there's data frames. What's the big difference? So if I want to summarize this slide in one point, data frames have schema and RDDs don't. So if we drill down into it, so data in RDDs, they are stored as independent opaque objects, whereas in data frames, we have column names for different, even in the data object, there's metadata component, which has the column names and the data types for these data. And RDDs, they do process optimization. So Maria was digging deep into it. And so what it means is we give the core Spark API something to do. It builds a directed acyclic graph out of it, and then it launches a pipeline, data pipeline. Whereas data frames, because they have additional information on top of that, it uses this schematic information to do further optimizations. For example, Spark knows that the age column is integer, so it knows which data to expect and which compression algorithms work best with integers. So it uses this sort of information to further optimize the data pipeline. And in terms of usability, when you look at RDDs, you tell Spark what to do, how to obtain the data you need. And you try to conceptualize everything in terms of key value pairs, tuples, and you refer to all these tuple indices. Whereas in data frames, you tell it what you need. You tell it, okay, I need this data frame and I need these columns with these following criteria, and the optimizer figures out the rest. So one thing before we leave this slide, RDDs can be transformed to data frames and vice versa. So without further ado, let's go to the tutorial. Okay. So yeah, so let's just skim through the first bit, because so the first code snippet, it's just vanilla Spark API, I mean core API, using text file to load this data. And so if you can see, yeah, I mean Maria explained to you, every line is a JSON object represented in a string. But if you look at this JSON, for instance, you have column names. And when you look at it, you can have an idea about, what the data types are. You can see that the review ID is a string. You can see that the Unix review time is a long or an integer. So when you have this sort of information embedded in your data structures, you can directly load it into a data frame. So there are two ways that you can use to, load data into a data frame. One way, the first way is the easy way, where you just dump the file path into the data frame API, and it figures out what data it contains, what are the column names, what are the data types. And the second way to do it is the developer can manually define the schema and say, okay, here's the data set, this is the schema of the data set, comply with it. So to do all these things, first you need the SQL context. So when you work with the core RDDs, you work with Spark context. When you work with data frames, you need the SQL context. If you want to get more creative, there's Hive context. But for this tutorial, I will use the SQL context. So first we check if the SQL context is working. Yes, it's working. So in this code snippet, what I'm doing is I'm loading this JSON file using the JSON file function in the SQL context with the file paths. So here I'm not defining anything about the schema. So Spark goes ahead and it will figure out the schema. So now you can see, in contrast to the earlier result, now we have a row object with different column names. And we have strings, we have tuples, we have decimals, we have all these different data. And one handy function that you get in these data frames is there's a function called print schema, which you can just use to observe what sort of a schema you end up with. So if you look at this, you have the row object. Inside that you have these different columns, and for each column name you have a data type and you have a nullable Boolean flag. So you can actually, so the second way is the manually specifying the schema. So if you, to do that, first we have to, specify the schema. For that, Spark provides you these type classes that can be found in, PySpark SQL module that can be used to define these schema data types. So what you can see here is the schema that I defined for the earlier data set. So I have this review ID, async, reviewer name, helpful, all these column names, and I have these variable types, the data type, and this flag here is the nullable flag. So you can say if this variable can be null or not. So here in this particular phase, I am not actually assigning the schema to the data, I'm just building it. So something you can observe here is that some of the fields are missing. So if you look at the summary field here, which is missing in the schema. And then there's the Unix review time. So let's just start off with this. So I will give you 3 minutes, of which every 1 minute I will give you guys a clue. Let's try to, build this schema. So first I will give you one clue. Every field is a struct field, which has a column name, which should be the column name in the JSON file, which has to have a data type, and which has to have the nullable flag. For now, let's assume it's true. Is anybody typing? No? Okay. So, yep, I'll give you the first hint to make it more interesting. So, this is what the column would look like column name. I mean, each column will have a struct field similar to this, and the data types would have to change depending on, so you can refer to the schema that Spark inferred to get some help from there. Okay, let's do this now. So first, let's implement the summary field, which is summary, and summary according to this is a string. So we have implemented string type before. So string types comes here, and it's, yeah, let's say it can be now. And the next one is Unix review time. So put that here, and that is long. So we haven't implemented long here. So let's implement long type. It worked. So if you want to get more, like here there are a couple of data types that I have implemented, but if you want to get the full overview of all the data types and their requirements, parameters, so on and so forth, you can go to this link in the notebook, and it will give you all the details about different data types. So now we build the schema structure. Now we have to apply that to the data set we have. So I'm using the same function, JSON file function, that is used to read JSON files into a data frame. So I'm using the same file paths, which is a string of the file paths. But additionally, I am passing the schema inside as a parameter. So when I do that, I get the raw object, yeah, with the schema that I applied to it. So from there, now we've loaded the data set. Now let's discuss about, so like what can data frames do. So data frames, most of the functions that you can find in RDD, they have a counterpart in data frames. So for example, map has for each function, select function in data frames. Map partition has its for each partition counterpart. Filter, there's a filter in data frames as well. For the flavors of group by key, reduce by key, you have a group by function, which is very similar to SQL. And yeah, join, you have a join. So let's just dive into some of the operations that you can do with data frames and just get on with it. So first what we will do is we will filter certain columns from a data set. So if you're using SQL, you use select to do this. If you're using RDDs, you use map to do this. So what we do here is we use the select statement, and so we build this applied data frame by applying this schema in the earlier stage. So we are doing a select on this applied data frame, and I am selecting the asyn, overall, review text, Unix review time, and yes. So once you run this, you get the picture. So you have the columns that you need. And something I also want to point out, this column df, like dot show function, it's very similar to first or dot take function in RDDs, basic RDDs. It just lets you, visualize the result and, see the data. So here I would like to do a small exercise. So map in RDDs, they can be used to select columns. At the same time, you can use it to do an operation on a column. Let's say, add +1 to a score, or divide it by a constant, or something like that. So do you guys think if the select statement could do that? Who would say yes? Who would say no? Okay. Well, the answer is yes. So you can use, so I have another exercise here. So what I'm trying to do here is, so there's a helpful, there's a field called helpful in the data frame. I want to use that. And what I want to do is, so the helpful field is the numerator and the denominator of, how helpful it was from out of this many people, how many people called it as helpful. So what we actually need, like in terms of data science or whatever, is that actual fraction. So let's now implement how we do that operation. I'm kind of skipping the exercises because of the time constraints. Well, but you'll get the idea. So you have applied df and the helpful column, which is a tuple which has two long integers in it. So you have the numerator and you divide that by the denominator. And yes. So now what I did here was, so you can do column-wise operations on select. And now the other problem we have is this guy. So it's when you want to do the next select in the next stage, you don't want to deal with this column name, do you? So would anybody have an idea how we could rename this column? As? Let's try as. Helpful. Now, let's try this as a string. No. So so the point is, as doesn't the keyword as doesn't work with the select statement. So in a data frame, how you do it is you get this product, and now you have this produced data frame object, and you run the next step on this object, and there's a function called with renamed column. Let me check that out. Yes, with column renamed. Renamed. And the arguments you give this function is, the first one is the existing column, which is this whole thing. Because by the time we get to this dot, this step of this transformation has already happened. So at that point, what you have is this column itself. So what you do is you take that, you put it here, and you rename it to helpful. So yes, so we did this division, and now we can see loads of null values here. Does anybody have an idea why this could be? Yeah, good. So we have this division by 0, and so null values and missing values, they are a very, very common problem in big data. So those who have worked with R and pandas data frames, you already know there are functions that could address this problem. So in this section, I will introduce 2 more functions to deal with this missing data problem. So there's 2 functions, which is the drop NA function, which will drop the records that have missing values, and the fill NA function, which can be used to replace missing values with a default value. So there are 3 ways you can validate the nullness of a record. One thing is, you could assume if any row, any column is null, you can assume I have to either discard this or whatever. And if all the values are null, then that's another criteria. And the other criteria would be, you have a subset of columns that are that you require to be not null. So you have this subset keyword, which can be used to define which columns you need to drop or replace with a different default value. So once you do this, you have all the helpful zeros, and so whenever I don't have an overall, I've just dropped all those reviews because they are not important to me, let's say. And moving from here, so we have the same function as similar to filtering in basic Spark RDDs. So here what you do is you have this, let's say now I've called this the dense df because it doesn't have any missing values. So dense df dot, you do the filter, And inside this, anybody, so my goal is to filter all the reviews that have an overall score greater than or equal to 3. Anybody have any guesses on what should go inside? Like maybe the first keyword? Is it a lambda or a column name? Okay, good. It's a column name. So you put the column name with the data frame name, then df dot overall greater than or equal to 3. And yeah, lazy Spark filter df dot show. Yes, so now we've got everything that's greater than or equal to 3. We put 1 here, yes, it works. So, okay, now we filtered everything. Now it's time to start shuffling. So in cluster computing, there's this transformation which involves this activity called shuffling, where you have to actually move the partitions around and restructure the whole data set. So one way, I mean, in basic RDDs, you have group by key, reduce by key kind of functions to do this. So similarly, in Spark SQL, you have a group by function. Normally, it should be it should be associated with a summarizing function to get tangible results, like, for example, count, sum, average, max, min kind of a thing, because you get a collection of records when you group by something, and if you want to represent that in one value, you can run something like one of these summarization functions to do that. So here, what I'm doing is I am grouping all these reviews by the overall score it's got, and I am building something like a frequency histogram. So I have the filter df, from that I group by overall, and I do a count to summarize the result. So when I run that, yes, so I can see a lot of people are happy. So then let's move to joining data frames together. This is also kind of similar to basic RDDs. So to start a join, you need 2 data sets. So first let me just run this. This is just loading it as a text file. So here I am actually, so this is the product data set. So I'm defining a new schema for the product data set. And here you can see there's the map type. So if you look at sales rank is a dictionary of string keys and integer values. So that is what I'm defining here. I have the sales rank, map type with a string key and an integer value. So this works. So I have a little question. So imagine, like, yeah, for the rest of the tutorial, I don't actually need this related field or image URL or sales rank field. What might happen if I remove this from the schema and try to apply it to the data? So there are 2 options. The schema will fail, or it will work fine. Who's for 1? Answer number 1.
You create a new data?
Yep. 1.
It should work.
Okay. Who's for 2? That it works fine. Oh, you want it to work fine or fail? Fine, cool. Yes, it will work fine. So you remove these 3 guys, and it works just fine. So now I have the product data set and I have the reviews data set. So in this code snippet, I am just doing a simple join. So here what I'm doing is I have the filtered DF, which is the filtered version of the reviews. I'm joining that with the product data frame that I just loaded to Spark. And as the second parameter, I am telling Spark what is the field that should be used to join these two data frames. And yeah, in the same step, I am piping a drop NA just to get rid of anything that doesn't have a title, just for like my own use. So when I run this, yes. So the key difference between RDD and the data frame here is that if you want to do the same process with an RDD and you have this, row of tuples or row of like a dictionary or whatever, first you have to run it through a mapper where you get this async field as the key in both the data frames, both the RDDs, and then do the join, and then run another mapper to convert it back to the data format that you want it to be used. So in data frames, you don't actually have to do that. You just tell what you need to Spark, and it does all the required processing under the hood, and it do it in the most optimized way it could find. So you have this enriched views now. It's realized, and if you have a look at it, you can see that there's the async. So there's the async of both the data frames, which is the same, and now we have fused the review data to the product data. So yeah, the final bit, final bit about the data frames. Then you can save data frames. So I won't go into detail about saving the data frame. One small thing I want to tell is, so there are multiple platforms that you can save in. You can do it to the local disk, HDFS, S3, and there are so many other plugins. There are different formats, including Parquet, JSON, so on and so forth. And there are, like, when Spark ships, it already comes with like gzip, LZ4, and snappy compressions. So it's like you have so many options depending on your practical implementation and your requirements. You can decide how to save your data. So before I dive into Spark SQL, let me get back to the slides just to change things a bit. So now you guys might, like some of you guys might be thinking, okay, now we learned about RDDs. Now we learned about data frames. They both do the same thing. And you should ask, like, why do you even have to use data frames, right? So to answer that, I get to this benchmark that Databricks released about a couple of months ago. So this is like they tried to aggregate 10 million integer pairs, and this is the number like in the same cluster formulation, and the results that they achieved. So what we can gather from this is that both Scala RDDs and Python RDDs, they have to get hands-on with the programming language. Like Scala performs better than Python because it's closer to JVM, and Spark is written in Scala. And Python, when it wants to convert everything to Scala, it has to do all these conversions, do the Py4j translations and everything. So what happens in the data frame API is that it's just an API sitting on top of an optimization engine. So what we actually code is just an expression of what we need. And instantly what Spark does is it converts it into a different optimized plan, and it carries it out in the same way. So that is the reason why this Spark Python data frame and the Scala Python data frames perform the same. At the same time, because it doesn't have anything beyond its control, like Lambda functions, so on and so forth. It doesn't have to actually worry about giving any sort of control to the developer in terms of the optimization. It can handle everything together. So just to understand this more, I will briefly go through what happens when you write a Spark SQL query or a data frame, like data frame query. So you have this data frame or Spark SQL query at first, and this unresolved logical plan is like the bare form of the query that you submit to Spark. And from that, so Spark has this catalyst optimizer, which has a catalog which keeps track of, what tables, what data frames are available in my context, what data frames are connected to which tables, which functions are registered to which Python functions, so on and so forth. So using that information from the script that we submit, Spark builds its own logical plan. And then it takes that logical plan and it optimizes whatever the steps that can be optimized. That's something similar to query optimization. And after getting that optimized logical plan, it generates a series of physical plans out of it. And using several cost models, it figures out what is the most efficient physical plan, and it executes the query. So just an example about how it moves from this logical plan to optimal logical plan, we all have an idea about query optimization. So if we take an example, here my query would be, okay, I need to join these products and reviews together from the ASIN, and I want to filter any review that was made for products that are more than $50 in price. So the normal way to do it is like you scan it, you join the two together, and then you filter out the valid lines. So if you think about it, you can actually do the filter on the products before doing the join, and you will have less number of lines in the product data set before the join happens. So that will optimize the join straight away. And Spark, especially if you use data frames and intelligent data formats like Parquet, it can go further down the pipe. And for instance, if you want to do a query with certain columns, and if you're using Parquet, it will send that columnar access, the required columns deep into the reading scan phase. And you can actually do the filtered scan while reading the data itself. So this is how these optimizations are achieved. So from here, we'll do a bit of Spark SQL, which should be pretty easy. Okay, this guy, yep. So Spark SQL, it's very similar to normal SQL you use in day-to-day life. So here, because it has the same functionality as data frames, I'm not going to elaborate step by step on different functions of SQL. Instead, what I'm going to do is I'm going to take about 2 queries with multiple functions and show you guys how do you do it. So from that, you will get a good understanding about different keywords, Spark SQL keywords, and then you will get an understanding about how multiple functions can be used together to make complex queries. So in this first example, so to start with, now I was talking about this thing called the catalog. So when you have a data frame is just it's a data object with a schema, but the SQL context has no idea about, when you have SQL, it has no idea about what if this is a table or what. So in order for us to map these different data frames to this Spark SQL space, like the world, you have these functions called register functions. So you can use this one function called register as table to make a link between a data frame and a table reference in your SQL context. And so here what I'm doing is I'm reading that Parquet file that I saved just, did I save it? Oh no. Okay. So I'm loading that Parquet file back. And then, so what I'm doing is I have this review data frame that I'm loading now, and the product data frame that I loaded earlier. So I am registering both these data frames as tables in my SQL context. So I run this, and at the same time I'm just, this print is just to check that if the data sources are loaded properly. So now we can use these reviews and products table keywords inside the SQL, inside our SQL commands, and catalog will know, okay, products refers to product DEF data frame. So now we have this query where I am selecting the 10 minutes. Is in review text, overall price from these different data frames, which are registered as tables with the join, and I am filtering anything that has a price of more than $50. So yes, so now that is how you register tables. At the same time, if I have 10 minutes, yeah, I'll quickly go through this for like in the next 5 minutes. So there's another thing, if you have used Hive before, you have user-defined functions. In SQL, you have stored procedures. So similarly, there's a way in Spark SQL where you can introduce functions into the SQL space using this other function, which is called register function. So what I'm doing here is I have a bare Python function, which I am registering as to lowercase in the SQL space, and then I can use it in a query where I do the to lowercase. And here we can use as to rename the field because it's SQL. And you run this. So here I have an example where I have done a few lines of code where I have loaded something in a data frame, converted it to a normal RDD, done a mapper there, converted it back to an RDD, back to a data frame, and run some SQL queries on it. So the whole take-home lesson from that bit is that you can mix and match anything inside the Spark ecosystem to best serve your requirement. And from that, just I'll get back to the so register function. It looks really handy if you want to do some complicated thing. It's it looks like a very useful tool. But the thing is, when you introduce the register function into the SQL space, you have to realize that there's actual Python code which is being introduced, which the optimizer doesn't want to touch. So at that point, the data frame has to convert things to Python and do that communication and all that. So the chart that I showed earlier, those performance guarantees do not really hold when you do something like register function. So if you are working with a process heavy function and if you want to use Spark SQL to do that, you might have to consider if it is worth to do it rather than do it in the core RDD form of the data set. And finally, yes, inferring versus applying schema. Inferring schema is easy, is convenient, but then by default what inferring schema does is it reads the first line of the data set, and alternatively you can tell it to sample from the data set to a particular ratio. But if you are not really sure that if that sampling ratio would not give the full picture about the data schema structure, then that might become a problem. So personally, I prefer to use apply schema wherever I work with data frames because I know what I'm handling with. At the same time, Spark knows what it's dealing with. So yeah, less room for error. Developer defines the schema, but yeah, just a bit of development effort. So yes, so there are links. So there's the data set and so the data frame. There are some useful links about blog posts about data frames. And if you are really interested in learning Spark and getting to know about it, I would really recommend you to one thing: go through all the slides that Databricks is releasing in their SlideShare profile. And then they have excellent talks in their YouTube channel about like tech talks, internals, and these different application case studies. They come really handy when you want to really get hands-on and work with them. If you want to get some, so with Spark 1.4, they've really worked on the SQL stuff, and they have a very good documentation with some programming lessons. So that might be of help. And yeah, questions? Yep. And at the end, we are hiring. So yeah, if you like Spark and if you like to work with us, work like us, please contact us. Yep, and yes, you may fire your questions now. Yep.
You said there was a performance.
Yep.
Your own Python functions.
Sorry?
Sir?
You don't need to touch it.
Oh, okay.
Yeah, you said that there's oh God, that's loud. You said that there's a performance lag if you map your own, if you apply your own functions to the data frame. But if you use the RDD, sorry, did you say again that if you map it using the RDD, then the performance, then it deals with it a lot better?
Well, it will do the same, but it all depends on, let's say, if you want to run, if it's one simple function, that's fine. But sometimes you might find you can, rather than writing a complicated function which you will register to the SQL, it's rather easier to convert it to a data frame, run through like a 5-step process and get back. So,
okay.
I mean, it's just a very, it's more or less like a heuristic thing. You have to think and then decide what would be, like you could do a few benchmarks.
No, because I just remember using a pandas data frame, and I used my own custom written ag function for the to aggregate them together on a group by object, and it took so much longer to do it than the pre-written one. So that's why I wanted to ask.
Yeah.
Or the number of partitions.
Oh.
Hi, thanks a lot for your tutorial. I was wondering if you're using Amazon S3, what are the best practices of using Amazon S3 and with a Spark cluster that is deployed on EC2? So the data is on Amazon S3.
Yes. So, well, best practices. Yeah, I mean, you must be surely using the Spark EC2 script, is it? Oh, are you using EMR? Oh, the storage.
We have a lot of data on S3,
okay.
And if we are to deploy a cluster on EC2, should we, to analyze this data on S3, should we move it to local storage first, or can you just create RDD or data frames from data that is stored
yes.
on S3 directly?
So what we do is we pull from S3 directly, and.
So we don't move the data. I mean, we just apply. We created RDD saying the RDD is in S3 in this file path, and then we just do the all the functions that you need. Spark figures out when it needs to cache, when it needs to do anything.
Oh, so you can just directly work with
Yes.
Yes. So yeah, I mean in text file, Parquet file, there's S3N protocol. You can just give the URL and pull straight from. Yeah, I mean that's what we do.
And your files are in Parquet?
Yes, most of in the sense, mainly, like it depends on if we want to do a batch process, we think about it. But if we want to do more or less like ETL stuff, kind of, then we use something like Parquet, because then we only have to pull what we need. Yep.
Thank you for the tutorial. I just have one question for Spark SQL. Is it possible to specify the execution plan? Because the optimizers try to do the best, but maybe, I mean, I've seen it in SQL, sometimes you can do better, but in SQL it's very, very hard to tell it how, in which order to do the joins, the filtering.
Sorry, I didn't get the question.
Is it possible to specify the execution plan in Spark SQL?
Execution plan? I wouldn't really do that, because, I mean, the whole point of data frames and SQL is there is a lot of work that's gone underneath to, optimize everything. So what do you mean by an execution plan?
Because I've seen it in SQL, sometimes the optimizer gives you a plan, it's not always the best.
Yes, so I haven't really, dig that deep into doing that sort of stuff. Right now, like, we are fairly satisfied, and yes,
okay.
It works great.
Thank you.
Hi, thank you for the tutorial. What are the best practices to manage UTF-8? I'm getting a lot of issues converting from... Yeah, you will be very UTF-8, the string. So when I load data from JSON into a Spark data frame, that's working. But when I save it, it breaks Any?
Unicode.
Yeah. But how do you deal with that?
I have problems with it all every day. So yeah, I just encode it, and I mean you have to encode.
When you read the file, you encode it?
Okay.
Yeah.
You want to come here?
I mean, I'm not an expert in Python or SQL.
Yeah, we are pretty
I
much
just
done,
say
yeah.
code, UTF-8 or whatever encoding is used. Depends on how it's been encoded.
All right, thank you very much, guys. Have a good day.